Dear students, in this video I will be helping you to understand the parallel communication interface done between microprocessor and the input-output devices. So for interfacing an input-output device, we need an interface IC or an interface circuit. Here for parallel communication, I will be using Intel 8255 as an interfacing circuit. When you look over this Intel 8255, it is called as programmable peripheral interface. The name of it is programmable peripheral interface. It is used for parallel communication. You know that communication is done by two methods. One is serial, other one is parallel. In parallel, many data are sent parallelly. Here 8255 helps you to send your data parallelly with help to the input-output device. So what is the advantage of using 8255 is that it improves the interfacing capability of 8086. So it makes it very easy to communicate with your input-output devices very easily with the help of this IC. When you take this 8255, it is a 40-pin integrated circuit and it is used to design and you can interface many different elements or many different systems with your microprocessor. It is also flexible and it is very economical. The pin diagram of your 8255 you can look over here. Totally I said that it consists of 40 pins, and when you look over the pin diagram you can see there are 3 ports available. This is port A. You can see here port A. It consists of 8 pins. Port B, you can see port B is available over here. Port B also consists of 8 pins. PB0 to PB7, PA0 to PA7, and port C also consists of 8 pins. Apart from 3 ports, you will have a read pin, you will have a write pin, you will have a chip select, you will have a reset, you will have 8 data lines for transfer of data, you will have a supply voltage VCC, you will have a ground, and you will have 2 pins A1 and A0, which helps to decide which port am I going to work with. So here, with this pin diagram, I have said that totally 3 ports are available, port A, port B and port C. Now these three ports are classified into 2 groups, group A and group B. So when you take group A, this group A consists of port A and port C upper. What do you mean by upper is that it consists of 4 upper bit data. Similarly, group B if you take, it consists of port B and port C lower. Port C lower in the sense it will be PB0 to PB3, PC0 to PC3, and port C upper means PC4 to PC7. Okay, so the C port is divided into 2. First 4 lower bits will be under group B. Second higher 4 lower bits will be under group A. So this is how the ports are classified in your 8255. So when you take the signals of your 8255, you can very well see here the signals. As said earlier, you have got 3 ports. PA0 to PA7 is port A. Your B port, PB0 to PB7 is port B, and port C is classified into 2. PC0 to PC3 is your lower port C, and PC4 to PC7 is your upper port C. And you will have 8 data lines, D0 to D7, through which the data is communicated between your microprocessor and the input-output device. You will have a chip select, you will have a reset, you will have a read pin, you will have a write pin, you will have a ground, you will have a VCC. Apart from that, remember you have got 2 important pins, A0 and A1. This is the one which decides in which port I am going to operate. Am I going to operate in port A? Am I going to operate in port B or port C? That will be decided by this A0 and A1. So here, when I take these ports totally, when you take your port pins, I said 3 ports are available, so 3 into 8, totally 24 input-output lines, which will be individually programmed. You can program each and every line individually. So it is classified into 2 groups, group A and group B, and port A, port B and port C, all the lines are identified with the help of these parameters. Okay, so now, when you take this chip select, you know what is the role of a chip select. Chip select is used to select this particular IC. So if a chip select is low, which means that the 8255 chip is selected for read and write operation. And you got a reset pin. The role of your reset is once the reset pin is set to high, when it is logically high, then all your outputs will be disabled and all will be converted into an input port. That will be done by this reset pin. The data lines are used for communication of your data. D0 to D7 is used for communication of your data from the devices between your microprocessor and that of your input-output device. So read pin, you know, role of a read pin and write pin. Read pin is used for read operation when it goes slow. Write pin is used for write operation when it goes slow. That is reading a data from your input-output device or writing a data into your input-output device will be facilitated by 8255 when these pins are turned low. Then A1 and A0, as said earlier, it is the address input lines which is used to select on which port I am going to work. So when you look over, this is my control logic of your 8255. Chip select, when chip select is low and your A1 and A0 for different values of A1 and A0, the ports will be selected. Supposing your A1 and A0 both are 0, port A will be selected. So A1 is 0, A0 is 1, port B will be selected. A1 is 1, A0 is 0, A1 is 0, A0 is 1, port B will be selected. A1 is 1, A0 is 0, port C will be selected. When both are 1, the control register will be selected, which means that what control I am going to do. So that control register will be selected. When chip select is 1, chip is not selected, which means that whatever input you give for your A1 and A0, now no operation will happen in your 8255. So now the block diagram of your 8255. So when you take your block diagram, the simplest block diagram of 8255 is given over here. You have got the ports, the different ports are put over, port A, port B and port C upper and lower. So group A consists of port A and port C upper, group B consists of port C lower and port B. All these are connected to the data bus. You can see here this is my system bus. All these are connected to the system bus. And you have got a data bus buffer. Data bus buffer is the place wherein the data will be stored temporarily and it will be communicated to the devices. So this data bus buffer will be connected to this system bus which is available over here. You have got a read-write control logic. This control logic is the one which is going to control your entire 8255. So these read-write control logics consist of read operation, write operation, A0, A1, reset and chip select. Okay. So all you can see this read and write, this control logic is connected to group A, group B and these groups are interconnected to its own ports. Port C and port B upper, group B is connected to port C lower and port B, and group A is connected to port A and port C upper. So this is my simplest block diagram of 8255. Yes, the definition of all the components is put over here. The data bus buffer is used to store the data and transmit the data. Your read-write control logic is the one, it is the control circuit which controls your 8255. It consists of all the control parameters like chip select, read operation, write operation, reset, A1, A0, everything is put over in this read-write control logic. Then you have got your group A and group B controls. Group A, you know, group A consists of your port A and port C upper, and group B consists of port B and port C lower. All those will be grouped under group A. You will have different controls for group A and you will have a different control for group B. Similarly, when you take your port A, it has got 8 pins. You know that port A consists of 8 pins. These 8 pins can be operated in 3 modes, mode 0, mode 1 and mode 2. Similarly, when you take your port C, it is operated in only one mode, that is mode 0. When you take your port B, it can be programmed in mode 0 and mode 1. Okay, so with this, we have learnt about the block diagram of 8255, what is the importance of 8255, what are all the pin details of 8255 and what are all the components that is present in 8255. All those concepts have been learned in this video. Thank you.